So today during RAP we're going to be looking and reviewing types of numbers, mainly rational, irrational, how to go from a fraction to a decimal, all of those sort of things. So let's first review what rational and irrational numbers are. Rational numbers, if you remember, the formal definition is basically that I can take a number and write it as a fraction. If I can take a number and write it as a fraction, then it is considered to be rational. When we think about that in terms of decimals, a rational number is going to have a decimal that either repeats continuously or that it terminates or ends. Only repeating and terminating decimals can be written as a fraction. So rational needs to be written as a fraction. On the other hand, we have irrational. Irrational numbers cannot be written as a fraction. Basically, irrational numbers are square roots that are not perfect squares. They're square root numbers that aren't going to come out nice and even for you, that you'll get a decimal when you square root. Also, pi is irrational. Some of the other more specific numbers that we deal with in math. Pi is the only one you're aware of right now, but there is actually a number e, and e has a value. E would also be irrational. So looking at the first one, all you're doing is telling me, is this rational or irrational and why? And we're going to break today's lesson up into 3 sections, and I'm going to do one of each of the type of problems, then give you a little bit of time to work and back and forth. So the first one, you'll notice that it has that little bar above the 2. Because of that little bar, we know that that decimal repeats. Because we know that that decimal repeats, we know that that number is rational. Why do we know it's rational? Because it has a repeating decimal. So I'm not looking for much in the way of explanations, just why did you say that that was rational? Can you write it as a fraction? Is it a repeating or terminating decimal? Can I not write it as a fraction? Is it not a repeating or terminating decimal? So go ahead, I'm going to ask your teacher to pause the video for a minute. Try the other 4, so up through problem 5 on your own, and then we'll get started again and go over those answers. Looking at number 2, square root of 9. You should all recognize that the square root of 9 is a perfect square, giving us an answer of 3 when we evaluate it. That is a rational number. 2 basic reasons. I can write it as a fraction. I can make it 3 over 1. It's actually also called a terminating decimal. 3.0, that decimal ends. Number 3, we have pi. Pi is irrational. Two reasons. You can either write that the decimal does not end or repeat. You could also just say that you cannot write pi as a fraction. That also works. 2/7. 2/7 is rational. Why is it rational? It can be written as a fraction. How do I know it can be written as a fraction? Because it was given to me in fraction form. And if you were to actually find the decimal of 2/7, it actually does start to repeat. The 857 actually starts the repeating process. It's a longer repeat than we typically see, but it is a repeating decimal if you're going to go that route. And then number 5, the last one I asked you to do for me, square root of 10. Square root of 10 is irrational. Why? When you make that a decimal, the decimal never ends or repeats. Now we're going to look at converting to a decimal or a fraction. If you're going from a fraction to a decimal, it's pretty easy. You're just going to plug it in the calculator. So for 6, you're going to do 42 division sign 9, and then calculator is going to give you 4.6 repeating. Make sure you do put that bar above the repeating pieces of the decimal. If you're going the opposite direction, if you're going from a decimal to a fraction, remember that if it's a terminating decimal, you're going to place it over its place value. So that would be 23 over 100, because the 3 is in the hundreds place. If I'm doing a repeating decimal, I'm going to take my decimal and put that in the numerator. In the denominator is how many 9s, a 9 for each repeating digit. So because here it's only one digit, the 3 that's repeating, I only put 1 9 in my denominator. If, for instance, it was 0.313131 and I had 2 numbers repeating, both the 3 and the 1, then I would put 2 9s under that fraction bar in the denominator. Go ahead, I'd like you to try the other 4. I'm going to ask your teacher to pause the video, and then we'll go from there. So in 7, you're just going to change it to your basic decimal. You're going to get 0.857142857 Hopefully you're noticing that that is not a that is a repeating decimal. It starts repeating again at the 857. So that one is considered to be a repeating decimal. The 3.6 repeating, you're going to leave the 3 alone. I have one repeating number, so that's going to go over 9. We do need to reduce 6 and 9, both divide by 3. 9 divided by 3 is going to give me 3. So 3 2/3 for my final answer for that one. Number 9, I have my repeating decimal. I have 3 numbers that repeat, so that's going to come over 999. You do need to check and see if those reduce. That will actually reduce by 3, giving me 125 over 333. Number 10, you have a terminating decimal, so you're going to put the 125 over 1,000 for in the thousands place. You should notice that you can reduce both top and bottom of them at least by 5, but you can actually reduce them by 125, and you end up with 1/8 as your final reduced fraction. Basically, all we're going to do in 11 is we're going to put these numbers in order from least to greatest. So we're going to find their decimal equivalents, and once we have the decimal, then we'll be able to put them in order from least to greatest. So the square root of 85, that gives me 9.2. 2 pi gives me 6.2. Square root of 56 gives me 7.4. And 3 root 15 gives me 11.6. I didn't need to go the whole decimal length. When you plug these into your calculator and evaluate them, you're going to get pretty long decimals. You only need enough so that you're actually able to compare them. So now that I have my decimals, I should be fairly easy to put them in order from least to greatest. Make sure you write them back in the original format. So 2 pi goes first, and then the square root of 56, and then the square root of 85, and then 3 root 15 at the end. Go ahead, try the other 4 for me. I'm going to ask your teacher to pause the video one more time to give you a chance to finish those last 4 problems. So number 12, in order from least to greatest, you would have the square root of 12, the square root of 24, and the square root of 27. For 13, you're going to have the square root of 40, square root of 58, square root of 75, and the square root of 92. 14, square root of 130, square root of 142, 4 pi, 8 square root pi, and 2 root 95. And for 15, 3 root 6, square root of 102, square root of 143, and 5 pi. If you have any questions on what classifies something as rational or irrational, how to put them in order, how to convert between fractions or decimals, please take a few minutes, come over and see me during Flex, and we can get all that cleared up.